So good morning. Thank you all for coming. It's great to see such a large crowd in support of this event on this absolutely stunning spring morning in February. We are IARPA. The I is intelligence. IARPA is really an interesting place to be. We sit at the open end of the IC, where it is that there's the theory of when you're facing an adversary, you can either hide or you can run fast. We're at the run fast end of that spectrum. So we want to work out in the open, access the best minds and best ideas wherever they are. Had some pretty successful investments to date. We were early investors in AI, we were early investors in quantum computing, and we still actually have a strong hand in the quantum computing roadmap. So we've been around for a while and doing interesting things. But really it's what's new, what's next, with the goals of avoiding technical surprise and making sure that we achieve overmatch. That's not something one typically says in the intelligence community. That's really more of a DoD thing, but I think it really applies. So what's over that horizon that we need to be paying attention to, or what are those ideas that we should be accessing to ensure that we're ahead of our adversaries? How do we achieve this? As I already mentioned, we really do look at reaching the best minds where they are, the best ideas, and that's focusing on the scientific method. We invest pretty heavily in test and evaluation. For those of you who worked on IARPA programs will know, we really do kick the tires and do sort of a thorough scrub to understand what it is that's been developed and making sure that we understand how it can be applied. So pursue a scientific method, thorough review in the community, and full and open competition again to access the best minds and best ideas. We are cross-cutting across the entire IC, so that's the wheel of SEALs, for those of you who've seen it before. That's a lot of agencies with a lot of missions. If we are interested in something that aligns to a single agency, then the suggestion is usually that they can figure out how to pursue that. We, again, want to look at these foundational things like NGen, which will have utility across the community. Main thing here, a very large mission space, which again makes it fascinating. See through space. I have an Army background, so I prefer subterranean through space, but many diverse needs. This is the IC mission and vision statements. I've just added the highlighting to kind of convey how IARPA ties into this. Agile, integrated, innovative, and resilient. Provide options, find the best technology, try and move quickly. And again, on the resilience side, that really comes down to giving people diverse options. IC mission, timely, rigorous, apolitical, and insightful. With the current administration, the apolitical is something we're emphasizing, but that's always been part of the mission. All right, so switching gears a little bit, talking about the Office of Collections, we see the IC as fundamentally data-centric, right? Trying to get novel sources of data and then process that into intelligence. So collections, that's the office that I run, is sourcing the data. And then we have the Office of Analysis, which is taking that data and processing it into intelligence. So collections, we break that down as sensing. So that's novel sensing, new phenomenologies. How do we work with them? How do we understand them? How do we sense them? So that's novel sensors. And then also starting to look into what we call intelligent networked on autonomous sensing. So that's distributed sensing. If we have large arrays of sensors, looking at depth of sensing, multiple types of sensors, how those work together, how we would fuse those to get a more interesting product. Sensing platforms, autonomy is important. That can be something that's static, that can be something dynamic, that can be large numbers of things that's dynamic. So investments on our side would be on the autonomy side, but also power for endurance, everything that the IC does that's expeditionary, has a battery or some power source. So that's an area of interest. Communication of data, it doesn't make sense to have data if you can't get it to where it needs to be, and that's fundamentally what NGen is about. And then hardware to process the data. We do look at edge processing as an important part of our mission, and we also hold the mission for quantum computing. This is a slight variation on that same set of things. These are my priorities. So anything in italics here are things we don't currently have a program. We have had historically programs and are interested in new programs. And so that's me shilling for ideas. NGen is a great program, but obviously we're interested in other ideas beyond that. We don't currently have a program in autonomy. We are looking at some ideas there. We have the Smarty Pants program in the microelectronics and edge sensing side of the house. That's a really neat one that's embedding sensors and electronics into textiles. Integrated photonics, another interest area. Won't talk about that. Quantum sensing, looking for the right value proposition there. DoD has significant investments in that space. I think there are some unique IC angles to that, and we are considering that. Advanced sensing processing technologies, we have the SCISS program, which is looking to detect waveforms in environments. The idea being, the challenge being twofold, right? One is using a software-defined radio, scanning a large bandwidth and looking for where energy may reside or signals may reside. And then once you've identified those, then categorizing them, right? So is this something I expect? Is this something unusual? If it's unusual, what are the properties of that? And then Picard, which is looking at detection of aerosols, both sampling directly, if you have access to the aerosol plume, and standoff sensing. And so that has some novel applications and things like if you have a factory and you don't, you suspect them of producing, say, narcotics, you can look at the plumes that come out of that and get a good sense of what the chemicals in that environment are. On the edge and expeditionary power systems, we have the resilience program, which is now wrapping up. That is a battery effort, so with two key thrusts. Thrust number one is to have power systems that can handle both transient high current loads as well as having long endurance. So that's useful for something like a VTOL UAS, where it may need to take off, fly for a while, and then land. The takeoff and landing being particularly demanding on the battery. And then the other track is having batteries that survive harsh environments, principally on the temperature side. If you have a device that needs to sit in a connex on a runway for a long period of time, it's really nice when you pull it out of the connex that it still works and the battery still functions. And also very low temperature conditions as well. So improving the range of performance for batteries. And then Solstice program, which is looking at power systems for both satellite and terrestrial applications, really optimizing the design for collection and use, but have that as a design problem, not looking specifically at, it's principally solar, but not necessarily, but looking at sort of the net system efficiency as opposed to just the single element of that. And then what additional elements can we advance to improve the net system performance? Next generation communication systems, we've got Equal P, that's taking a relatively low frequency antennas and making them electrically small. A lot of application for that, and NGen, which I won't talk about because that's Adam's job. On the strategic side, autonomy, I think, has range across all of these because of the places we would like to have access to in order to sense. Microelectronics, we have the Agile program, which is looking at how do we optimize and design systems to look at large data problems with so massive data sets with sparse information within those, sparse interesting information within those data sets. How do you consume large amounts of volume very efficiently? And that's both a computing architecture on the software side, and then also on the hardware side, how do we co-design those together in order to get efficiencies? And they've demonstrated orders of magnitude improvement for the kinds of problems that we care about, and I won't say any more about that. Quantum computing, the Entangled Logical Qubits, or ELQ program. That's basically, we've now demonstrated that logical qubits provide value, i.e. if I have multiple physical qubits, I combine those to form a single logical qubit. That logical qubit has now been demonstrated to have better performance, that's in terms of fidelity and lifetime, than the sum, or sort of the individual and the sum of the physical qubits. And this is a really important step towards quantum computing. And one of the challenges has been having qubits that have the adequate properties for computation. So we've now reached this point. Unfortunately, it does mean we need more physical qubits to make quantum computing systems. ELK is going off that next step, saying now that we have logical qubits, how do we entangle those to perform computation? So this is absolutely foundational towards quantum computing. And advanced sensing and processing technologies on the strategic side, we have the Central program that's looking at space debris. If you have a centimeter scale piece of debris. The average velocity of that is 20,000 meters per second in space, or sort of that would be the average collision velocity of two things, in geo orbit were to collide. That has similar energy to a hand grenade, but we're not able to track that with current technology. So we track debris larger than that, and there's a lot of debris in this population that would be mission ending. So we're driving these technologies to detect smaller and smaller debris down to 1 millimeter, in fact, is the goal. Really neat result we had on this about 2 months ago is they were able to detect the westward needles. And I won't talk about that because I'm running out of time, but westward needles are, it's worth looking up if you don't know what they are. I think it was Lincoln Labs had ownership of this. They launched in the 60s, and they're basically 25 microns thick, so 1 mil diameter wires. So human hair is approximately 4 mils, 100 microns, and about an inch long, slightly less than an inch. These wires are floating around in space, and we were able to detect them from the ground, which is quite an astounding feat when you think about the ranges and scales. And then space systems environment, obviously Solstice plays into that as well. So just a couple of parting thoughts with regards to the program we're going to talk about today. I think everyone's obviously, you've bothered to show up for this, so you understand what the value proposition is. This is an incredibly important program. I think it's going to be foundational because it's going to change the way we do a lot of things. So I'm personally very excited about the NGen program. I'd say just things to think about, in terms of when you get to the proposal stage. Obviously, everything, we're still making decisions and learning about exactly how we're going to frame things. But, think about how you provide options, and that kind of comes back to a little bit the agility side as well. How generalizable is your approach? How adaptable is it, which is a fundamental goal. Explainability, I've been pressing Adam on this. In order for people to ultimately use these things, we need to have some intuition about how they're going to perform. So even though we're going to take on approaches that are truly generative, and we may not necessarily understand at the get-go, we would like to have ultimately some intuition about how they're making the decisions, or why they're making the decisions, or what the properties of those results will be. And that really comes to the utility, right? So having that diversity of function, but having some sense of how they're going to work, or kind of what are the bounds, how repeatable are they going to be, with the goal that they are highly adaptable. So that's a mouthful, and I apologize. But yeah, I'm very excited about this program. Thank you all for being here. And any questions on IARPA, anything about NGen, save those for Adam. Questions? Thank you.